So welcome everyone to this tutorial on SNOMED in the information model. And we have entitled it for new implementers. So when preparing for this the tutorial streams this year, myself and my colleague Kath, Catherine Priest. So hi, I should say my name. I'm Højen from SNOMED International. But we were discussing what type of tutorial we were missing, and both found that having the discussion around information models and SNOMED and terminology binding and how to do that, we need need more guidance on this in this area to help people coming into this field to understand how to start applying SNOMED and applying it in the best possible way, and to deliver those benefits and goals that you set up in your implementation project. So a bit of background: I'm Højen. I'm from SNOMED International and I work as an implementation support specialist. So my role is to support implementers working with SNOMED in achieving their goals with SNOMED CT. And I'll hand over to Kath.
Yes, I'm Kath Priest. I'm an education and product support specialist working in the education team, looking at mainly delivering sort of the implementation course. So working closely with Anna to find out what's going on the ground with implementations, to what's the best way we can get some education about that. And like Anna said, this was a big gap that we sort of found for new implementers of knowing where to start, and feel quite passionate about getting that basic information out there, really.
Yeah, so this will be the first of a range of new things I think we'll do in this field. So I'm trying to switch. So that's the first challenge. Let us see. There. That will be interesting if I had to do that every time. But okay, here's the outline for the next 90 minutes. We have divided into these three overall groups, but first that we talk a bit about what terminology binding is, talk about the role of terminology and information models, and why it's so important to do terminology binding and to do it well, but also talk about what makes terminology binding difficult and challenging. Then Kath will take over and talk to a range of different terminology binding principles. Some general principles, talk about subsets and value sets, expression constraints, and about the role of the concept model when it comes to terminology binding and how you can actually utilize it to ensure that you're right, using the right concepts from SNOMED CT in the right places. And then we have, if time allows, some examples and demonstrations. Now it works. That's great. So what is terminology binding? So as a bit of background to this, when we digitalize our health environments and introduce electronic health records or other clinical information system, we are doing it with a great motivation, because now we are digitalizing. Now we'll realize a range of excellent benefits just because we are digitalizing things. We will be able to have increased efficiency and accuracy, improved data accessibility. We'll be able to share data. We will be able to enhance patient care and improve patient care, because now we will have access to clinical data. We'll also have improved data analytics, decision making, decision support. We'll be able to communicate and collaborate better with our colleagues, our clinical colleagues, enhancing patient safety. Maybe we'll do fewer errors, so it will increase the patient safety. We'll have better documentation and may also be able to harvest some of the efforts when we do clinical documentation when it comes to increased billing accuracy and revenue. So these are some of the goals that I'm sure you are all thinking, yes, these are the goals. When we do these huge digitalization projects within healthcare, these are some of the things that we would like to achieve. The problem is that if you start to digitalize healthcare and develop and implement new clinical information systems with the perception that you take something that you have been doing in a paper-based form or in an outdated clinical information systems with a very fixed structure and no use of standards. Well, what you'll gain there is that the clinicians will probably be happy because the systems will look like something they know, and it will be very familiar to them. And that will increase the clinical adaptability. However, it will not support the interoperability and reuse of data if you just plug or put or create like a paper, an IT version of your paper-based records. So you really need to take that into consideration from the beginning of your implementation project. How is it that we can ensure that all these benefits that I was just talking about, how do we meet them with our implementation? And yes, we need to acknowledge that we need the clinical acceptability and of the clinical information systems. So that is one of the key factors that you need to consider, but you also need to consider all the other things. And one way to do this is by looking at how can we apply standards throughout the processes, throughout the implementation, because these standards are really required to achieve the benefits, especially when it comes to utilizing clinical data and clinical information across borders and even across the borders within a system. You also need to think about how you use standards and how you do things in a consistent manner. There are two aspects to standardization that I will talk about today. There are different levels and different range of standards that you need to consider, but for the purpose of SNOMED CT implementations, it's worth considering the role of the terminology and the role of the information model. So a bit about the terminology. It's the vocabulary. It's where you get the semantics. So let me just read out loud here that a clinical terminology primarily serves to provide a systemized and controlled vocabulary of clinically relevant phrases that can be used during data entry to provide a more precise and shareable expression than might be obtained by using free text. So we use the terminology to represent what clinicians in the decades have been writing in free text, but now in a structured and controlled form that allows you to reuse. Information models, on the other hand, are used to model and manage objects at a conceptual level, independent of any specific protocols used to transport the data. So you can say that SNOMED CT provides the content where the information model provides the frame. Let's dive into the terminology. So for those of you who had attended the introduction, this will be like a repetition. But SNOMED CT consists of more than 350,000 unique clinical concepts that are linked together via a set of semantic relationship. And if you consider that the image here on this slide, SNOMED CT really is a knowledge graph. It differs from many other classifications and code systems because it has this structure, because it is a graph more than it's a monohierarchy or just a list of terms. SNOMED CT is a terminological resource with this huge semantic network. And each of the concepts, they are linked together, as I said, via semantic relationships, and I'll come back to that. But we also have descriptions that provides the human readable representations for each concept. For example, you have the code here, which is the code for cardiac infarction, which we also call heart attack or myocardial infarction. In Danish, we call it myokardinfarkt, and so forth. You can have translations and you can provide the descriptions in other languages. So that's some of the additional features of SNOMED that we have. We are a multilingual terminology. Each concept is represented uniquely by this SNOMED CT identifier, and via a link between the descriptions and the concept using that identifier, we can provide a human readable representation. So, and that's actually key to SNOMED CT. So although that it is a huge semantic network, clinicians, when they use SNOMED, they would use the terms They shouldn't bother about this complex structure that goes behind. They should be using the clinical phrases when they document. So that's one of the key things for implementers to be aware of. Coming back to the clinical adaptability that I talked about before, one thing that clinicians will appreciate is to not see the concept identifier, but just displaying the terms and speak the clinical language. Just even though it's not free text, it is still a controlled vocabulary, but they understand the terms that are used. This illustrates the semantic relationships that a heart attack is a type of ischemic heart disease, a myocardial necrosis. It has it has an associated morphology of infarct and a finding site of cardiac muscle. And here it's worth noticing that these associations, these relationships differ. So they are semantic relationships because the type of relationship says something about the property that it represents, that a heart attack is a type of ischemic heart disease, but it has a finding site of cardiac muscle. So these associations, these relationships are quite important when it comes to understanding the property that it represents. We have 19 top-level hierarchies where these 350,000 concepts are organized in. Body structure, clinical findings, events, and so forth. And we'll come back to all of these because this is really the essence. We have 350,000 concepts organized into these hierarchies. Behind these hierarchies, we have this huge semantic network. And then we have SNOMED that's ready to be implemented because it's very comprehensive. And all these concepts in these hierarchies can be used to represent the broad range of clinical information that needs to be captured in and around a health record. Signs and symptoms, test results, observations, diagnosis and procedures. Also things like functions, abilities, medications, family history. There's a lot of information that is captured in the records. It's not only about procedures and diagnosis. When it comes to research and data analysis, we want to be able to not only look at what were the diagnoses and what procedures were performed, we need to also be able to query on a range of other aspects in the system. So we need to include all that information, and SNOMED supports that via the broad scope. And our objective with this tutorial today is to say, okay, we have a broad scope, we have many use cases. How do we start our journey? So that was the background on SNOMED and the terminology part. Let's dive into information models. So this diagram here illustrates a range of information models, and I'm sure that when we talk about information model out here in the lobby with some of our fellow SNOMED implementers, we think about different things when we say information model, because we think about maybe the models that we are used to working with, or the models that are relevant to the field that we work in. We think about something different, and sometimes we need to really take a step back and talk about when we say this, when we say information model, what is it we mean? Because information models are many things. At a high level, it's a model to organize the different types of meaning that we want to represent. But they can come in different types. So here we have categorized them as models of use, models of meaning, communication models, analytics models, knowledge models. Models of use could be a model to define how does this user interface look? What are the data entry fields? What type of fields are they? Are there dependencies between these fields? That would be a user interface model. And that's a type of information model because it tells you something about how we organize the information in the user interface. You can also have a storage model. That would be like an ER diagram, for example, showing how you organize your data in a database level or at a storage level. That would be another type of information model. And they do not look the same, right? Because they speak to different users and they use different technologies. So there are different models, but you need to be aware of them when you use SNOMED for data entry, for storage. And when it comes to communication, you also need to consider what is the model? How do we structure that information? Hence, what is the information model we use when we communicate and share data? So that would be things like, and it's something we talk a lot about in this community as well. An example would be fire models. So how is it we structure communication messages with fire? So that is an example. But there are also other models. So just bear in mind when you sit down in your implementation projects and discuss, but what does the model look like? Make sure that you outline this. What model are we talking about? For what purpose? And what are the data elements? And we'll come back to that. But let us take a look at an example of these communication models that we have in FHIR. So in FHIR, we organize information that is relevant to be exchanged within healthcare. And they organize information into these resources. So this is an example. This is just a screenshot taken from the FHIR website on what does a patient resource look like. And here you can see some of the information that you would want to capture about a patient: the name, the gender, the address, marital status, maybe even a photo. There are different things that you would want to capture about a patient. So in FHIR, you can see some of them are mandatory, or most of them are actually optional. But there is also the cardinality to say, when you represent a patient, what are the cardinality? What can you expect to find in there? And you create profiles to say, well, in this context, this is what we capture always. So you don't have to apply all of these. Similar for procedure, you can see there's a range of information or data elements in this resource. For procedures, it would be things like, what is the actual procedure that has been performed? What is the reason why it was performed? Who was it performed on? Was it the patient? Also something about who's recording this information, and maybe the body side. There are different things, and they all stand out here. And each of them we call data element. So our information model consists of data elements. Third example, also a FHIR resource, the condition resource, where it will be things like the code for the actual condition, maybe the body side, the subject, so who has this condition, the onset of the condition, and things like that. That is what you would represent in a condition resource. So these FHIR models, they all represent like the frame. What are the things that we can, if you think about a shelf, what are the things that we can put on each places of this shelf, where the SNOMED, the terminology, is actually the content, the things that we put on it. This is also something you'll see when you dive into the FHIR specification. And this is still the problem or condition resource. So this is just another view. The next slide you'll see is another view of this slide, this diagram here. And what I want you to point your attention to here are the types. And here you can see that one of the types that we have here is codable concept. So in the FHIR spec, they also say what type of content would you put on this shelf? and codable concepts is one of the type that you would use, for example, for severity, or for the code of the problem, or for the body side. And here is where we would enter a SNOMED concept. So these data elements says something about where SNOMED is applied, and SNOMED is applied where we have the codable concepts. One thing I failed to say when we started this is that if you have any questions as we talk, this session is 90 minutes, and if you are thinking about something and you want to ask, please just raise your hand. We want to make it also a dialogue if there's something you want us to elaborate on. So here is an example of a JSON representation. And here I just want to show you the code data element. So this is from the condition resource. And here you can see on the code, this is where we represent the code for the condition. In this case, it's the ischemic stroke disorder that is represented. So in these information models, within these data elements in the information model, we represent the terminology resource. And in this case, we say that it's SNOMED. It could be another vocabulary, but in this case, we say that it's SNOMED, and we also represent what is the concept that we represent here. So if we were to exchange this with another organization, this is where they would look to find out what did this what were the conditions for this patient. And they would also review the other data elements, because if the body side had a field, does it have that here? No, not in this example, but it could have a body side as well. And then you would also want to look at that and the other data elements. So that was a background on information models. So now we've talked about the terminology, we've talked about the information models, and now we come to the main focus for today, and that is on, so what do we do then? How is it that we link these two things together? And we do that by terminology binding, because a meaningful, it's not about deciding, should we go the information model route or should we go the terminology route? No, that is really a misunderstanding if that's the thing you have in mind, because you have to combine these two things together, because a meaningful electronic health record requires that SNOMED is appropriately bound to a structured information model. And that is what we call terminology binding. So all these slides was just like the background for what is terminology binding. And that is when we create an established link between the information model artifact and a terminology artifact. A terminology binding can include additional metadata, such as the type of binding, the scope of the binding, and that can help us to interpret the binding consistently. And we'll get more into that. So why is terminology binding important? And in short, it's because otherwise, if we think about that, the anticipated benefits I showed you in the beginning, that's why it's important. That's so that we can represent data consistently and accurately in a manner that can be understood across various organizations interested in using that data. Terminology binding, as you will see today, will provide faster and more accurate data entry or input, because it will allow you to say, when I enter data, for example, if it's a user interface, if I enter data into this field, what is the scope or the range that I can search across? It's also very important for data quality and utility. When you apply a comprehensive terminology as SNOMED CT, if you gave a clinician the whole of SNOMED CT and asked them to find diagnoses for something specific, if you ask them to use the browser, I'm sure that although all of these clinicians were the most clever and smart persons, they would end up, if they didn't have any knowledge on SNOMED, to select something different. And we'll say more about that. So that's also one of the things that we can achieve with good terminology binding, is to ensure that we reuse SNOMED in the right places for the right things consistently. And that's important for interoperability. So the linkage between SNOMED and information model is essential so that we can communicate between our information models. And also, even though we have models that differ, we are able to compare. Why is it difficult? In the previous slides, it has looked so good. There has been the ellipse with the terminology and one with the information model, and we were able to define them. And this is what that is used for, and that is what we use the information model for. Great. But the devil is always in the detail, because this is a more correct representation of terminology and information model, because there is a significant overlap. And that is the essence of why terminology binding is difficult, is because there is overlap between the terminology and information model. So where the terminology is excellent and representing what a disease is, what a procedure is, the symptoms and so forth, and the information model is excellent at representing dates, times, durations and quantities, there is this area, I would say gray area, but I can see it is yellow here on my slide, but all the contextual information. We are able to represent some context in SNOMED, and some of that context you can also represent in the information model. And if you then start to do that inconsistently, that transformation between various models with good terminology binding can even become difficult. So you need, as part of your implementation, to consider this very carefully. How do you deal with context? So a SNOMED CT concept, for example, if you took the clinical finding concept for breast cancer or disorder concept for breast cancer, that meaning, that how you should interpret that concept depends on the model and the structure where it is applied. So here you see 3 examples of where I have entered breast cancer into a field. But for the medical doctor and the clinicians, they will be able to interpret this by looking at it, that this is a family that the patient has a family history of breast cancer, that the patient had breast cancer, that the patient has breast cancer. So that is good enough that the clinician can understand that in this context, machines should also be able to assess that breast cancer in this context is not the same as breast cancer in that context. And what makes it even more difficult is also that you can then have different structural representations. Sometimes you may want to just have one field where you say, this is in a data element for family history diagnoses. In system B here, we have a very limited model. We just have a data entry field, but we have a good terminology that supports the representation of context. So we can say family history of breast cancer. I don't need that in system B. That's the decision here. And over here in system C, they have said, oh, well, we have 2 fields, one for breast cancer and one for the diagnosis and one for the relationship, for the subject of the family. So where you can, for the subject, and here we can say that it's the person in the family. So these 3 systems have bound a data element to SNOMED CT, and they all make sense in this situation. But you can see that it becomes difficult if we just share the terminology. If we didn't care about the models here and just took the content, the terminology concepts, it would be 3 different stories that were told. And this is what I try to illustrate in this slide. So something that is captured in a family history field, in the case breast cancer, and we just share the terminology without caring too much about the model. We just want to know what SNOMED codes do you have over in your system, and we forward those codes. What the receiving system would then understand from this is, well, okay, there's a patient with breast cancer here. Well, that breast cancer was captured in a data element for family history. So here we have a really patient safety critical situation, I would say. And this is why you also need the model. So when you communicate across organizations and across borders, you need to both care about the model and the terminology. So now I'll hand over to Kath, who will talk about some of the binding principles.
Yeah, thanks, Anna. So in this section, Anna's obviously gone through sort of the background of what the terminology bindings sort of and information models are, but now we're going to sort of try and look at some basics of what the general principles of when you start looking at terminology bindings are. The sort of things that can actually help guide you with your bindings. So looking at what subsets and value sets can support those, and ways to develop effective subsets of value sets for those terminology binding fields. And to do that, we'll just cover a little bit about the expression constraints and then some recommendations as well that might help you from an implementation point of view to work out how to implement terminology bindings. Okay, so we're going to start off with the general principles. So I think, like Anna's already mentioned, there are so much information that you want to record in an electronic health record. So you can see in this screen, we've got things like diagnoses, findings, procedures, tests, medications. But then it's always that thing of, well, which part of the terminology do we start with? So we know that from a diagnosis, findings and results point of view, they would tend to come from the clinical finding hierarchy. And then for things like the procedures and tests, care and therapy, we would use the procedure hierarchy. But then there's also things like social circumstances. So which part of the terminology does that come from? So there are always specific parts of SNOMED that you can use for particular fields in an information model. And so the thing to bring up is that there are kind of 2 types of terminology bindings. We've got value set bindings. So these tend to have a specific list of sort of concepts that you would use to populate a particular data element in an information model. So like you can see here, I click. So we're looking at this case, if we've got a fracture information model, the type of fracture you could pull from sort of a value set of different fracture types that you can see here in this list. And this would then populate sort of the diagnosis type field in an information model in a patient record. And then you have meaning bindings, which can be used anywhere really in an information model. So if we're thinking about these bits from the type point of view, these can be used sort of fracture to actually mean the actual attribute of that diagnosis that's there. On to the next one. Okay, so the most common type of terminology binding that tends to be used are value set bindings. So as you can see here, we've got a value set is the set of coded values that is allowed in a data element. So these can be developed either by using a query or rule to sort of collect these particular types of clinical meanings in a value set, or they can be specified by an enumerated list of concepts that people might want to just pick from SNOMED CT. But you can't just use any bit of SNOMED CT. Again, there are certain bits of SNOMED which relate to a particular sort of data element or data field that you want to record in a patient record. So like from a diagnosis point of view, you might want to use all the subtypes of disease. For procedures, again, subtypes of the procedure hierarchy, and even more specific, if you've got a surgical procedure field, you'd then use an even more specific area or part of a sub-hierarchy to record that information. This is, I often think, a really interesting slide to see, and this was actually presented, I think, quite a long time ago at one of the expos in 2014 by Dr. Jeremy Rogers, and it comes from an actual study that was done on the data entry of emergency room diagnoses. And I think it just shows you what happens if clinicians can just access all parts of SNOMED CT. So they're using things just to search. They've got access to everything. They've searched for things like temperature. But you can see here that they've got different semantic tags like an attribute or physical force, when actually you're probably looking for the disorder or finding concepts for these things. And I think this just kind of is evidence of why you'd want to constrain that data entry to a particular part of SNOMED. Yeah, so there you can see, if you read on the bottom, just going to read that out, of overall 11% of all these coded data items were very obviously coded to clinically impossible or improbable categories that you wouldn't expect. So when you're thinking like the alcohol example, it's probably that they might have alcohol intoxication or they've presented kind of drunk to an emergency room, but actually the substance is being recorded from that point of view. Okay, so what's one of the things that can help you with sort of simple bindings with these value sets? But subsets or expressions constraints are really all that we need to be able to implement simple bindings to these individual fields of an information model. So how do you create good subsets? I think is probably the next bit we're just going to cover here. So I'm just going to skip onto there. So a subset of is basically a group of things, a smaller number of things that are being together within that group. So within SNOMED CT, a subset just references particular components, whether it's a concept, a description, relationships. So they're just those concept IDs that are referenced in that subset, but related to a particular version of SNOMED CT. And these tend to be published sort of from that point of view as a reference set. So this is just basically what a subset is. And what might we use subsets for? So we might use them to constrain search and data entry. So value set for data entry, if we're talking in this case against the information models. but also to specify value sets used for communication, reporting and decision support. So again, say you've got somebody with a particular condition and you're wanting to check that you don't want them to be prescribed a certain medication, that you would want to be able to say, all these people who have this condition, from a decision support perspective, please don't, let them be prescribed this medication. And then we've also got that you can specify groups used for retrieval and analytics. So that might be someone, again, with a rare condition, and they might be just wanting to attend a particular clinic. So you're perhaps only funded for patients with a certain diagnosis, and you want to be able to recall all those patients to that. So it could be used for sort of reporting, retrieval and analytics as well. So when we're talking about a value set, so a set of concepts representing from one or more code systems, a subset of terminology codes can be used in the context of an information model as a value set. And so they're usually there to constrain the content of the coded data element or data type that you're wanting to populate in the information model. So if we look at this example, so we've got a medication order that you're wanting to say record the medication name, the dose, the route that the medication's administered, the frequency of that medication and the duration. What this example shows here is that you can actually use a subset of SNOMED CT as a value set for this information model. So we've got this for the route. So you can see the code there and then the display term, what concept might be used. Okay, so we've talked that subsets can be built from an enumerated list, so just the list of codes, but they can also be built from a query. So that means you might want to develop a query for all types of surgical procedures, or a query with all disorders with a morphology of information. And the way that we can do this is by using the expression constraint language here. So we can use an expression to say, please give me all the surgical procedures in SNOMED and or all the disorders with the morphology of information. So we're just going to go over a little bit about the expression constraint language. So it's basically a computable rule that can be used to define a set of clinical meanings. If we have a look at the types of kind of operators, I suppose, we can use in the expression constraint language, we've got showed by the less than arrow at the top. I can't see, yeah, which will show you all the, which will, if you use that against the substrate of SNOMED, it'll give you all the subtypes of a particular concept. And the same with the one with the two sort of less than arrows gives you the descendant or self of all a particular type of concept. And these tend to be the more common kind of queries that people will run. There's also one way you can bring back certain members of a reference set if they might be used for a particular purpose. The other thing that I wanted, a key one that is really useful that's quite new for the expression constraint language, is the history supplements at the bottom. And this helps you query over any inactive content that's been inactivated, which will have been at some point entered in a patient's record. So you'll still want to be able to bring that back from an analytics point of view. So yeah, so you can learn more about the ECL there, and I think you're also doing a bit more in-depth tutorial, aren't you? I think on ECL tomorrow. Yeah. But here's just some examples. So this is just in terms of, so this expression would give you all the subtypes of an appendectomy. So if you're thinking you're in a particular field in a record and you want to be able to bring up the particular types of an appendectomy, you can run that query, and then this would help you build a reference, a subset to sort of capture all those things. So you can see just from the browser there, the example of the different types that it brings back in terms of a laparoscopic appendectomy and emergency one. This is just showing a bit more of a complex expression that you can do. So this would bring you back all types of disease with an associated morphology of fracture. So if you were, say, in a fracture clinic and you wanted to be able to record any particular type of fractures, this is a query you could use to generate a value set that would then enable you to input all the different types of fracture. So that just brings you the list there. But then say if you were in a fracture clinic, but you had a specific lower limb clinic and you just wanted to constrain that even more, we can see from the original expression that we've done for all the disease concepts to return that with an associated morphology of fracture. We know we'd get fracture of tibia in that list, but you might just want it even more specific to just limit it to that one. So it comes back in the top one because it's got an associated morphology of fracture in its relationships of that concept. But if you then make that query at the top even more refined to include the find insight of bone structure of tibia, this would just bring back all the different subtypes of that concept. There might be a question I'm just preempting of, why don't you just use the fracture of bone disorder hierarchy to do that top one? But it might be there aren't those kind of group of concepts available in the terminology, so it's often useful to be able to do these complex queries to make sure you get the right concepts for your value set that you're trying to create. So one more example of a common thing you might use is, for example, if you've got, say, some nursing staff in a hospital that are wanting to, say, record concepts in their record for particular nursing activities. So they might want to find, right, well, which concepts in SNOMED CT are going to be suitable for us to have as a value set to help us record all our nursing activity. And there's a subset available, or reference set, the nursing activities reference set. And this query here that you can see with the little up arrow will bring you back all the members of that reference set that you could bring out from the terminology there. Okay, so we're now just going to talk about some of the recommendations of where to start with the principles of terminology binding. So I think Anna's already said it's so important to know what your information model is and the elements of that information model to know where you're even going to start in terms of overlap or dependency between the terminology. So it's also important to understand the content requirements, the dependencies between the terminology and the information model, but then knowing how to create value sets that reflect that intended clinical meaning. And match any requirements that you have for that terminology binding. So we're going to go through knowing what your data elements are included in your information model. So we're going to have a look at two examples of a fracture information model. So we've got information model A and information model B. So in information model A, we've got the type of fracture that we want to be able to record as coded text. We've got the body site of the fracture, but also the laterality in information model A. So all those fields can have that coded information or value set used to help clinicians select that information for those features. And then information model B, we've got just one type of fracture. So they will probably want all that information in that one field, whether it's location, laterality, the type of fracture as well. So now we need to understand the content requirements and dependencies and the implementation logic that might be able to be used for these information models. So if we have fracture type subset here, which we've got fracture of humerus included, we've got closed fracture of hip, open fracture of bone, this would be ideal for information model A. You can use any of those concepts. It gives you the detail that you might need. But if we look at this in terms of information model A, we can already see from the fracture of humerus, even the top one, well, that if that was used for the type of fracture, it also includes the body site in terms of humerus from that point of view. So there are often sort of those dependencies between the information model, and that's one of the things that it's really clear to be careful of what you're recording where. So if we just have a look at a bit more at information model A, we've got the fracture body site subset that we might use to populate the body site, and then we've got another one with the fracture type subset there. And I think the issue that this creates in terms of dependencies, there's kind of two. One is that it might mean the clinicians have to record information twice. So if they select fracture of humerus in that field, They then have to also populate the body site field with bone structure of humerus. So it's that duplication. So it's kind of redundant from that point of view. The also thing is sort of the inconsistency of data and potential clinical risk that you could also create, because they could record closed fracture of hip, but then also record that it's a bone structure of radius. So it's also being aware of that risk that if you've got a mixture of things in your different subsets, what this might cause. And I think one of the things is, if you can use implementation logic to reduce this redundancy and consistency. So some information models might have that implementation logic to be able to say, if the consultant's picked fracture of humerus, it will automatically populate the body site field with bone structure of humerus. Go on, Anna.
Yeah, and this exact example is actually, it's such a good way to show how SNOMED CT can actually provide some value, because you can use the defining properties of concepts in SNOMED to pre-populate. So based on your selection under the type, in this case, if you had taken the closed fracture of hip, it could pre-populate the body side hip structure in the body side field. But that is dependent purely on you having that logic in your system. So if you don't have that, don't go this way.
Yeah. And I think that's sort of what we're going on to next, is that if you can't use that implementation logic, you know, this is where it's really valued that you sort of create your value sets in a way that intends the clinical meaning, but ensures there's no overlap in your sort of terminology and information model. So for example, with the type bit here, you might just stick to a fracture type subset that sort of captures the open fracture of bone, so the particular type or morphology of a fracture, and then you would have your body site subset that specifies the actual bone where the fracture occurred. And then, for example, in information model B, you might then develop a subset that does just do the fracture type with location, because you know that everything can go in that one field. This also is just a key thing that helps you to show that it's important to balance that content to ensure that the subset reflects what you want to be able to capture. So if you were creating a procedure subset and you search for blood pressure, if you could search over the whole of SNOMED CT, you'll get the observable entity for blood pressure, you'll get the procedure for blood pressure taking, but also the actual finding of what the result of that procedure was. So if you're wanting a procedure one, you wouldn't want the observable, you wouldn't want the sort of finding concept either, but you would want the procedure bit in the middle. And then the other thing is also, if you're doing sort of smaller subsets, it's also worth considering the type of grouper concepts that are there. And I think it's always worth to know to create a good subset from this point of view. You don't want to include those in your subset. So if we bring out this example here where you've got finding related to ability to chew, you'd only want the bits that are underneath that grouper concept, because that actually gives you that clinical information of what the patient can or can't do, or what they have difficulty doing. Whereas the group concept doesn't give you any information at all. Yeah.
Yeah, and in this case, if you just jump back, Kath, it's not, we don't say that when you create all value sets, you should remove groupers. This is a recommendation for when you, for example, create a pick list with 6 to 8 values in a drop down. You need to make sure not to use groupers, because finding of ability to chew doesn't really make sense. And there are groupers all over SNOMED. So for small pick lists, you should go with those that represent the actual results of your observation. But it's not in the same way a problem if you have like a huge value set where you have a search engine supporting your search, because the clinician will search for the thing and they will select the actual finding as long as it's within the right scope of the scope of that data element. So if you search for something that this patient is able to chew, they would not, and then you would get both the finding related to ability to chew, but you will also find able to chew, and it's more likely that the clinician will select what they mean.
Yeah, and I think this is where we've kind of tried to do a bit of I want to say a cheat sheet. I think that's what we've been calling it a little bit, to know which parts of SNOMED CT to start with. Because there are the 19 hierarchies, and which bits can use sort of the bits that you want to use directly for clinical data entry. So the kind of boxes in green are the ones that we would say you could use straight away. So in terms of, you can use clinical findings in problem lists, in visit diagnoses, in results. Procedures, again, you can use in surgical procedures, for care and therapy, follow-up procedures. But then also, for example, events might be used for reason for attendance or procedure. The ones in red are quite easy for the ones that you say, just don't use these for any kind of clinical data entry. They don't provide any value from that point of view. However, the ones in the middle tend to be the tricky hierarchies, I think, for implementers. And the ones that really require that information model awareness to know what you're populating and to also know a bit about SNOMED CT. There's a little caveat also on this cheat sheet in terms of those ones that are marked with a star, that also, if they're used in terms of context within the information record, information model that adds certain context, you do need to have that awareness of the information model, for example, clinical findings in past medical history and procedures in surgical history. But again, there is the element of information model awareness that you need from that point of view. So I think this kind of just goes on to show why these ones are quite tricky in terms of information model awareness. So we've got this example of a dermatology clinic, and if somebody's just put elbow in from the body structure hierarchy, what does that actually mean? They've got an elbow? We don't know. It doesn't provide any information at all. It's just an elbow structure in a diagnosis. And also, if they just use mild from a qualifier value, it doesn't, again, tell you anything about a diagnosis, what it is, where it's from. So it's being that aware of what's there. So if we actually include that in relation to either a concept, another concept, or the information model for a condition, it actually then means a bit more. So you've got skin structure of elbow from the body structure. Oh, we know that then applies to the dry skin diagnosis. And we know that then it's a mild dry skin of the elbow. So it shows that how those these hierarchies actually support the definition or information of other concepts. But how are implementers meant to know that? You know, how do they know which of these hierarchies they can use, which are used to sort of add that meaning to other concepts? And that's where, like, the SNOMED CT concept model comes in, because that provides the rules of what can be used, which concepts. This slide looks awful, by the way.
I'll just make a comment to the previous one. I see in my brain, how I see this is that those yellow hierarchies, they are super useful, especially for defining pre-coordinated concepts, because we use them to define those concepts in the green hierarchies. But they are also useful for terminology binding, as we see it here in the slide on the body side and severity. But you can't interpret the meaning of them without the context of the focus, in this case, the diagnoses. So all these yellow hierarchies need to be interpreted in the context of where you are in the information model and the terminology of some anchor or the focus concept in this case.
Yeah, and I think this slide, even though it looks quite busy and it's not the best way, it was the best way we could think to say, well, actually, if you've got dry skin, which is part of the clinical finding hierarchy, this is the kind of concept model that sits behind that. So you can see that those are all the types of attributes that can be used for a clinical finding. We've got the types of sort of the finding site. We've got I can't read it from off the top of my head. The severity, you know, all those sorts of things that actually sort of provide the meaning of a concept. But we've also got the range, which shows you what variety of those hierarchies can be used to to provide that defining information about a concept model. So if we think about our dermatology clinic example, we've got the finding site, which attribute which corresponds to your body site, and then we've got the severity attribute that corresponds to the severity part of the information model that we could see in that sort of patient record entry scenario. So if we think about the finding site, what the values of or the body structures that can be used to record a body site, if you like, all come from this hierarchy of all subtypes of anatomical or acquired body structure. So if we use the skin structure of elbow example, you can see that's in that hierarchy there, that would be something that would be valid to be able to record in that field, because it's there as a subtype of those concepts. The same with severity. It's got the severities qualifier values that are used to sort of provide that value there. And you can see the mild example in the qualifier value. But how, again, do people know which hierarchies to use? Where's the concept model? So I think this is just an example that it's all in the editorial guide. So each domain that has a concept model, you can use that from an implementer's point of view to help guide your development of your value sets or your terminology bindings. But there's also the machine readable concept model. So this represents the SNOMED CT concept model rules, but in a way that the computers understand those rules, which are really important for your information model and your exchange of information. And then a really good tool, I would say, for implementers to use to help them with this building of the binding is to use the sort of MRCM browser. And this is an example, one of the clinical finding, but it's got the 3 sections in terms of it covers the domain or the hierarchy that it relates to. It then helps filter out the applicable attributes that are related to that clinical finding, and then what values you can use to sort of add to that attribute. So I'm going to just use our dermatology clinic example again. So, and you can also see that we've got the condition fire resource there, because that's kind of there to as an example of representing the information model that we're thinking how this might link with the terminology binding. So the main bit that we want to think about is this codable concept here, where to record the condition or problem diagnosis. And this would link with the clinical finding hierarchy, which then we know will be used to sort of populate the diagnosis field of the patient record. And then we can do the same thing, thinking about the severity codable concept. So we know this will relate to the severity attribute. So we can again use the clinical finding concept model to be able to identify that. And the same with the body site codable concept that you can see from this point of view is to use SNOMED CT body structures. So how do we find again the value set or the applicable values we want to be able to use from that point of view would be to use the ranges of that machine readable concept model to go from to find those results. And in this case, your value set might come further down from that hierarchy in terms of you might just want the skin structures because we're in a dermatology clinic. So you might just refine that even down, but it at least gives you a starting point to know which part of SNOMED CT you go to develop that value set. I think we're from that point of view. So maybe go through the examples.
Yeah. Thank you, Kath. Okay, so it's a bit of a mouthful to listen to all of this, and it's like if some of you have done the authoring courses, you need to sit down with that MRCM browser. You need to figure out, okay, yeah, these are the attributes that apply to this domain, and over here in the ranges, I can really see this is the applicable range that I can choose from. So it's just by getting into that MRCM browser and see the associations. And if you want us to show you, we are happy to do that in the break. But now we want to move on to some examples, other examples, not the MRCM browser, but the UI demonstration for a start. And some of you may already have seen this, but I'm going to show the expression constraint, how expression constraints can support can support data entry. In order to use expression constraints, you need to be bound up to a terminology server. You need to have an engine behind that can say, okay, if it's this expression constraint, then these are the concepts that are returned. So that's where the architecture is important, that you have a terminology server established. So let us just go to the UI demo. I'll not do the full-blown demonstration. I'll just show you this, and you can also access it on the snomed.org/UI. So this just is an example to show how a user interface, clinical user interface could look. And I want to show you this, that every S here indicates that these fields are bound to SNOMED CT. If we go to the patient details, you can see here on the smoking status, it's a drop-down list where each of the values have been bound to SNOMED CT. And over here with the genders, it's the same. But let's go back to the encounter. And next to all of the fields with an S, there's also an I on the other side, and that's where you can see the bindings. So for this field, the procedure field has been bound to all the subtypes of procedure. So that means that I can't enter diagnoses or pharmaceutical products or body structures here, but I can enter procedures. If you look in the diagnosis field, these have been bound to clinical findings. So here I can't enter procedure. Let me just demonstrate. If I was entering appendicitis here, and you can see it just shows as I started to type the string, and I can select appendicitis. And if I do the same down here, appendicitis, nothing shows up. Let us shorten it a bit. Okay, append, now I see appendectomy. And all of these options here are procedures. So this is a very generic way and flexible way of doing bindings, but it's also a way to ensure that you record findings in pharmaceutical products where you want to record a procedure. So for these very large search fields, binding to a terminology server, you can see here I'm bound to Snowstorm here. I could also use onto server. So Snowstorm is a terminology server that supports the Fire Terminology Services API. The same as Snowstorm, so I can just swap server now. And again, if I start to type, I will get the opportunity, but here, because this uses the Australian language reference set, I get other preferred terms shown. So this just shows that you could hook up on different servers. You can even apply different language reference sets. It's still the same binding. Another thing to show you here is when we discuss how that you can populate information based on the definition of concepts. So let me say I said that this was a hip replacement. It was or a knee replacement, something with the left knee. Could we do that? Yeah, we've done this procedure. It's a CT of the left knee. So because CT of left knee has a laterality, because the knee has it's the left, it's the concept that has been used to define CT of left knee. The procedure side for this is the concept left knee, and that has a laterality, which is left. And that is pre-populated here. So here we use the defining properties of the SNOMED CT concepts to populate the laterality. So the example that Kath showed, where you need to make the decision on should we exclude the body structures or can we allow them, will depend on whether you have this type of logic. So let us now try, and you can see I can't go in and modify laterality. So let us just say CT of knee. And pick that instead. Then we would see, now we can select the laterality. So now we are decomposing that meaning. And it requires an information model and a storage model where we separate this information. Yeah, I think the reason why we can do this is also that in SNOMED CT, all the body structures that are lateralizable, we put them into a reference set. So that machines have an automatic way to discover those body structures that you can lateralize. So where is it that we should enable the laterality field? So that is a reference set that comes with the international release. Okay, so I'm not going to give you more of this demo, but go to SNOMED.org/UI and then have a look at this.
Sorry, one thing to add from that point of view is that the ones body sites that can't be lateralized, you wouldn't be able to select
No,
anything in that.
you're
line.
right. I should have shown that. So for example, with the appendectomy, it would be disabled because you don't have a left and a right appendix structure. So that's how the reference set or the subset of lateralizable body structures are used, because it will check, well, the appendix structure is not in that subset, so it can't be lateralized. Therefore, we keep that field disabled. So now we have, and I'm just aware of the time. When you talk about something interesting, it tends to go very fast. We only have 20 minutes left, so we have some different examples, and I think we're just going to stick with the first and the last, because we also want to show you a small tool that can actually, where you can go back and practice these principles with terminology binding. So we also want time for this. But let's go into allergies and talk a bit about that. And this is the balancing and understand. This is just to demonstrate that you need to make deliberate decision about how you record your information. So even though also if you have a similar information model, there still are content decisions that needs to be made. So for example, in this case where you want to be able to record allergies of a patient, let's take allergies of a shellfish, and you're very welcome to jump in here. So if we did a search for something with shellfish in SNOMED, these are some of the concepts that we would get. And then you could ask yourself, well, which of these should we use when we are recording an allergy to shellfish? Should we, the organism, that's the shellfish itself? Should we do the regime therapy? That's in the procedure hierarchy. An allergy to shellfish is the condition itself, so that's maybe quite good. The observable is the act of observing if the patient has a shellfish allergy. The shellfish substance, maybe, or the toxic effect, that is probably more a manifestation. So here's an example where you could imagine a user interface where you have different options. And the question I'm really asking is, what lies beyond this shellfish here, this option shellfish? What concept do we use there? And there's not a single correct solution, because in this system that we have here, in our model, in this community where we have discussed this is how we want to record, we have decided that we want to record the cause of the allergy. So in that case, we would use the substance, shellfish. You may have another organization or another group of people who have decided, well, or a country. In this system, we want to record the actual allergic condition. So behind that shellfish lies another concept. And then you can say that's a problem, because what if those two organizations now want to communicate with each other? How can they understand? And that is actually, again, where the defining properties and how we define SNOMED concepts using these semantic relationships become important. Because if you document using the substance shellfish in the context of an overall context that is a type of allergy, you would be able to derive that then it's the allergy to shellfish. And those who are using the other approach where they record the diagnosis, allergy to shellfish, they can derive the substance that you're allergic to. So you can actually use the defining properties to link between models. And in this afternoon, we are going to have a session on information exchange, and we're going to show a more in-depth example. But it's just to say that here you need to make a deliberate decision about, is it the substance approach or is it the finding approach? But at the end of the day, it doesn't stop you from actually doing data exchange across these systems. So yes, it's about defining what is the scope of each of the fields. And none of there's not, as I said, none of these are false. These are perfectly fine bindings. We have the clinical reference group for allergy and intolerance and hypersensitivity. They have documented this in an implementation guide. So if you are in the field, if you're working on a project with specifically allergies, go in and read this guide. And there you will also see the bindings that they propose, and they specifically focus on the FIRE model for this as well. And we have created both the guide, you can find it there, and there's a demonstrator as well, where you can go in and try to see, and you can swap between the two approaches, whether it's a propensity-based approach or whether it's the substance-based approach, and how that all reflects in the FIRE resource. Because of time, I'm not going to go in there now. We'll jump. The point with the malignant melanoma is quite similar, but the slides will be available afterwards, and you can look at that. Well, maybe I should go do it there. Oh, I will.
Yeah.
Okay, I'll do it. So it's the same for malignant melanoma. When you are recording a thing like a malignant melanoma in a record, again, knowing the data, that's the whole point of this session, I would say, know your information model before you determine what concepts to use. So here we have different options. So if you do a search for malignant melanoma, and you'll see various concepts that could be used. And again, they may actually all be very applicable in different places of the record. So imagine here that you have a histopathology report, and it's the test result that you're recording. Well, then you want to apply the morphologic abnormality, because it doesn't say, it says something about the morphologic abnormal structure that has been found in this test without even setting the diagnosis. But in the diagnosis field of this EHR, you would, and when they have assessed the results of that test, they may want to specify that the patient has a malignant melanoma of back. And this is where one single diagnosis field, you would really want to be as specific as possible, because that would help with the communication between different clinicians and workflows, and just to have as detailed data as possible, to be as specific as possible. But in the case where you separate, you don't want to compromise the accuracy, but there you may just want to use the more general concept of malignant melanoma and then specify a body site. So now I am going to move to this terminology binding demonstrator tool. So in this demonstrator, and it's available, you can just access it. It's a long, even though it's a short link, it's quite long, but you can see it there on the slide. But I want to show you how you can easily practice. And if you can sit down with, you can even use it as you sit down with clinicians or people in your group to say, is this a good binding? So here you can specify a new binding. So that could be, if we want to capture malignant melanomas, for example. So the title is malignant melanoma form. There are different types. So here we are not binding it to anything. We'll just say that this is a title, and I'll add the binding. In a future version, I could imagine that we'll add the model meaning binding to this, but not for now. And now we want a diagnosis field. So I say this is the diagnosis. I can say, well, autocomplete is a field where you can just do a search, just as the one we saw in the UI interface. So I'll select autocomplete, and then I can enter my ECL. I may have used the browser to construct the ECL, but we also have just the ECL builder here. So you don't have to know the whole ECL syntax to do this, but here we want to find all subtypes of malignant melanoma. So I'll just say malignant melanoma, and I'll pick the disorder concept, and I'll say the descendants of here. So now I've constructed an expression constraint without knowing too much about the expression constraint language. And I'll just click OK, and it's populated here. So now I'm saying I have a field that we entitle diagnosis. We make it autocomplete so we can search it. And we use this expression constraint to populate the values or to specify the range that we can search through. We could also add a node. And I'll just say write something. I'll select, I'll just say select. I could have written search for the most specific malignant melanoma, if possible. So you could give some advice. So now I'll search for. And there you see. Now we have constructed a binding, and now we can search, but we are not getting, and we can see all the very specific ones. So although we do somewhere here, oh, we actually, I selected the descendants of, I didn't select this descendants of self. So by doing that, I don't get malignant melanoma in my result set. So let's just go and edit that. So I go over here and I'll go here. Because I only added one, and this is where you need to know it a bit, one single less than sign. I take all the subtypes of malignant melanoma. If I add just another one, I include the concept itself as well. So now I'm updating. Let's just try again. And now you see it's there. So now it's included. And that's the power of the expression constraint language. And also using expression constraints to specify your queries. It becomes quite flexible. So where you can, I would really recommend that. But of course, you need to still, maintenance is still a part of this, because when concepts that you use in your bindings become inactive and so forth, you need to be able to update it. So it's not that you completely avoid that part, but it is a very effective way to do good bindings. Let me just show you another field, just to show a different type. Let's do the laterality example. Laterality. And now say, well, we want options here. And I'll use the ECL builder. And here I would, in the full-blown example, we would now have gone to the MRCM browser. I would have found the attribute for laterality. That would have shown that all lateralities are found as a subtype of site, which lies in the qualifier value hierarchy. So what I need to write here is site qualifier, because that's where the concept model and the MRCM will help us to find that this is where I find left and right and left and right. And in this case, it's important that I don't select the double less than site, because site is a grouper. I don't want to use that, so I'll say descendant of, and I'll press OK. I'll add this binding, and now you see that it populates these three. And it's radio buttons, I can't select both. However, it's not so clever that I can say there should be a dependency between a body side field and the laterality. So this is just for practice, and it's for you as implementers to go back and explore, look at how you can define these bindings. So I really hope that you will go that, and you can give us some feedback on it. If it's useful for you, we would very much like to hear it, and anything, then just let us know. There's a data panel so that you can see this is how the laterality field would look. If I select something here, malignant melanoma of toe, you'll see that is how it would look. It's the diagnosis. So this is a proprietary form. This is not the standard fire structure or archetype structure or anything. It's just a proprietary form. But we do have the option actually to represent it as a fire questionnaire. And you can then download it as a JSON file. And you can upload it again if you want to look at it again. If you've created this very cool user interface and you want to show to your colleagues, remember to download it so that you can upload it again and show it to them, because this system doesn't save anything that you have made. Okay? Yeah. So it's really just a very lightweight tool. You can also load an example if you just want to show this to someone. And you want to maybe go and edit and try some different expression constraints. You can do that using the edit field. Yeah. So I think we'll actually have to leave the last example that we've prepared to, which is about context, to the version 2 of this tutorial. I'll just very briefly run over them, because this is about the fact that if you think about what I showed you in the before or early when we started, that the context, how you apply a concept and the context surrounding that information really changes the meaning. And that is what this example is about, that a procedure can be requested, planned, stopped, done, and a finding can be suspected and known absent. That's also valuable clinical information, but it can also be used as a family history. So how do you deal with that? We have a hierarchy, but that includes concepts where you can represent this information, but there are few concepts in that hierarchy compared to what you would imagine, how many suspected disorders you can have. You can have very many, you can have as many as we have disorders in the clinical findings hierarchy. So, and here we don't have so many. So it's a good idea, and it's a recommendation that you actually consider, and I'll jump through all these slides, but that you consider alternatives to using the situations, but you're using an approach where you are able to decompose your meanings. So what we essentially say is where you can and where the information model allows you to do it, try to separate it into these context-free parts and then represent the context in other fields in the information model. SNOMED has the situations and it provides some options for you, but if you want the real flexible approach, you should go with a good information model and a good use of the terminology. Yeah, I think I will leave it at that. And here, if you have any comments or questions. We have some online. We hope it has been useful, and we wish we had, apparently we wish we had 2 hours so that we can show you all the examples. But I think it's time for a coffee break, and I hope that you will enjoy the next tutorials or the next sessions. As I said, we are touching on this similar thing in the data exchange tutorial. And if you want to learn more about expression constraints and the use of expression constraints, from this session now you know that expression constraints are good at the terminology binding, but there are many use cases for expression constraints. Yeah. So yeah, Snowstorm, our terminology server, supports the expression constraint language. Yeah, and that is open source. Yeah. And yeah, go into the guide. We also, I wonder if our implementation support portal has an overview of ECL engines. Otherwise, it's a good idea to add that. So I'll definitely after this go and take a look. Yeah, so the specification for ECL is available and the syntax is also available. We really encourage people to start to develop ECL engines so we can see some good versions of that. Yeah, well, enjoy the rest of the expo. Thank you very much for coming.